call EMFs, and molecular formulas I call MFs. MIFs. We've got empirical formulas and molecular formulas. And it's really important, so you might want to highlight it and put a star beside it. An empirical formula is the simplest whole number ratio of atoms in a compound. So it's the simplest whole number ratio. So no fractions allowed. It's called an empirical formula as we get this information from an experiment. So empirical evidence. The empirical formula is often different than the molecular formula for the entire compound. So the molecular formula gives you the exact whole number ratio of atoms. And this is also on your sheet. So the difference between these two is one is reduced. So put a star beside that on your sheet. The molecular formula gives the exact whole number ratio of atoms within a molecule. So, example 1. What is the empirical formula for N2O4? N2O4. Is that in the lowest possible ratio? Ridgeway? Yes. So the EMF is NO2. You can divide both of those numbers by 2. So N1O2. How about C2H6? What's the empirical formula there? Mazzoni?
CH3.
CH3. 1 carbon, 3 hydrogens. How about H2O? So what would be the formula for the empirical formula? H2O. So in this case, your empirical formula and your molecular formula are the same. So this is your molecular formula. Sometimes your empirical formula will be the same as your molecular formula. And we're going to figure out how to determine that. So, example 2. What is the empirical formula for a compound whose percent composition is 79.9% carbon, 20.1% hydrogen? So if we assume a 100-gram sample, we have 79.9 grams of carbon and 20.1 grams of hydrogen. So always include your assume 100-gram sample. What's the formula for determining moles if we know mass? What do you think? What's the formula for small n? Okay. So write them in the same steps, so you're going down your page. You take the mass of your element and you divide by the molar mass of that element, and that will give you moles. Moles, you divide by the smallest number of moles. So which one's the smallest number? The 6.6. So divide both by the number of moles in the smallest number. So what we're doing here is we're going to find out how many hydrogens there are for every 1 carbon. Right? Because any number divided by itself is 1. Bless you. So what's the number of moles then for hydrogen? 2.99. You can round 2.99 because it's off by 100th to the nearest whole number. So how many hydrogens for that carbon? 3. So our empirical formula then is CH3. CH3.